Hello everyone. Today we're going to work on this exercise in Go language where we want to write a function that will call three services: service A, service B, and service C. We want to call those services using concurrency. So the first thing we'll do is we'll look at which services can run in parallel and which can't. Here we can see that service A needs some input and gives us the A output. Service B needs some input and gives us B output. And because B does not depend on A and A does not depend on B, we can run them in parallel. Okay? But service C here depends on both A output and B output. So our flow is that we can call service A and service B in parallel. And only after we've got the response from those services, we will be able to call service C. Right, so let's start by making it simple for ourselves. Okay, we will write the function, but without concurrency first. Okay, so funcs, let's call it, I don't know, call services, right? We're gonna need the input. Okay, so this is input that's provided by our program. And as output, we're just gonna give the answer from the C service. Okay, so we're gonna reply with a C output. And here what we'll do is we'll just write A, which will be the output from the service A. So A is equal to service A of the input. B is equal to service B of the input. And C is equal to service C of both A and B, right? Okay, so that's simple function, there's nothing, and then we can return C here. Okay, so simple function, nothing particular here. Let's just test it. So here I'm going to create some input variable. So let's just call it I. I is just some input. And I'm going to get C from call services with my input. And let's just print all done, right? Let's see if everything worked. Probably, oh, and I need to print C. So yeah, let's just print C here. Okay. Let's see how that goes. All right, so we got our first error here that says illegal types for operand print. Okay, so that means this function is not able to print this type C output, right? So I'm going to use fmt instead and printf hold on, and I'm going to use this like this, and this should fix our first error. All right, all done, and we have some empty output, which is good for us because we don't really care for the exact values. We're only looking at the flows of function calls here. Okay, actually maybe just so that we can see in the video a bit better, I'm gonna add some print statements here. So println service A is running, okay, and here I can add service A is done, okay, and then same for B, service B is running, and service B is done, and same for service C is running, service C is done, right? So that we can get a bit better visualization of println. All right. So if we look at this, it says service A running, service A done, service B running, service B done, service C is running, service C is done. All right, and then all done, and then we have our output here. Okay. What do we do now? So now we want to make this a parallel call, right? So we'll start easy, and we'll go with baby steps. How do I make a call to service A asynchronous? Well, I use a Go routine, right? I use a Go routine, and I need to use channels to capture the output of my service A. So I'm going to start by creating the channel. I'm going to create a channel, and we're going to call it A out. Right, so A out will be the name of the channel, and that will be a channel of A output. Okay, and then I'm going to start this in a Go routine. So I'm going to start Go func. Okay, so Go will start this function asynchronously. This is an anonymous function where I can write any code I want, and I need to call the function so that it gets executed, right? Because if I just do this, I'm declaring the function, but I'm not using it, right? So here I'm calling it, it gets used immediately. Now inside that function that runs now asynchronously thanks to the Go routine, I can create this variable A, call service A, and then what I need to do is I need to send this variable A into the channel, right? So I'm going to do A out, and I'm going to send the variable there. Okay? So this runs the service A asynchronously and then writes the output to the A out channel. But then I need a way that I can read that channel to get the variable back, right? Also, routines that write to a channel are responsible for closing that channel. So I need to close the channel from my service A function. Okay, so let's use defer, and I'm going to defer close the A out channel. What's going to happen here is the function is going to call service A, is going to write the value to A out, and then is going to close A out. Okay. The only issue here is if I don't read the value from A out, this Go routine will hang forever and the channel is not going to get closed. But that's okay because we can handle that later. Okay, so we just have to keep in mind that we need to read the value from there to let the Go routine exit. There's another way, a bit simpler for us here, that we can make sure that this Go routine exits as soon as it's returned the value to the channel, is if we store the value in the channel with a buffer. And because there's only one value we need to store in the buffer, we can do comma 1 here. So comma 1 here, which will make a buffered channel with a size 1 buffer. So what happens now is the Go routine runs as soon as service A has been called. It's written into A out. A out immediately writes the value. It's not hanging until someone is ready to read it because the buffer is here to store it. The Go routine exits, the channel gets closed, right? Now, if you read from a closed channel, you can read the values that are already in the buffer. So here we're safe, we're good. The value is not lost, okay? I can do exactly the same thing with my service B. Okay, so here just a bit of boilerplate, but B out is a channel of B output. I need it to be buffered for the exact same reason as before. I want to close B out. I have a variable B from calling service B, and I'm writing it to the B out channel like this. Okay, so that's good. Okay, so if I run this, actually we can't run this right now. It's not going to compile because I don't have these variables A and B. Okay, but I can go baby steps and I can just say A is equal to a value from A out. Okay, and B is equal to a value from, sorry, A is equal to a value from A out, B is equal to a value from B out, and then I run service C. Okay, let's just see how that goes. If we have any unexpected errors, it's good to run your code often. So go run is a very good command to use and abuse. All right, so here it says service B is running, service A is running. It's interesting because before we had service A running first, right? And service A terminating before the service B starts running. Here, no. Because we run them asynchronously, both the services run in parallel, okay? So they both start running at the same time or almost the same time, and then they both stop running. Interestingly, Here in the code, you can see I'm starting the service A go routine first, but the service B is running first. Okay, and that can happen because even though they start at the same time, inside the service code, the print statements might execute in some random order. Okay, and then that doesn't matter. What matters for us is they run in parallel and we can get the values back. Okay, if I run this again, I might see service A running first this time. Right, I didn't. Right, but like I said, it doesn't really matter. The point is they start running at the same time and they're done at the same time. Right, and here we're basically done. Okay, if the point was just call service A and service B in parallel, and then call service C, that's it. We did our job. Okay, but now what we're going to do is we're going to make this exercise a bit more complicated. What we want to do is we want this call services function to have a timeout. Okay, we want to in case the service A takes way too long to process, or the service B or the service C, any of them, or just the combination of them takes too long to process, we don't want our program to hang. So we want to add the timeout. Okay, and so new exercise is we're gonna add a 50 millisecond timeout to this call services function. Okay, so call services here I input, and I'm going to add a time.duration argument, which will be my timeout. Timeout. Okay. All right. And here, okay, so now we have this new exercise. How do we make sure that this call services function finishes under, let's say 50 milliseconds, okay, just assume, under 50 milliseconds as specified in the timeout. So first in main call services I for input, I'm gonna add 50 milliseconds, okay, right. What I need to do is here when I wait for service A and B, and here when I wait for service C, I need to make sure I don't wait for longer than the total timeout of the call services function. Okay, so what I can do is I can create a context. A context is basically something that allows me to cancel Go routines either manually or after a timeout argument. And that's exactly what we need here. So I'm going to write context and cancel is equal to the context module dot timeout. I don't have the context here, so I can just do context of background. And what is my timeout? My timeout is what's given in argument. Okay, here. Okay, I have a small screen so that you guys can see what's happening. I'm gonna write it like this. Okay, now let's try and run this, see if everyone's happy. Syntax error, expected new line argument in list. Okay, what if I do this? Does that fix it? Yes, it does fix it. All right. Now that I have this context, I can check if the timeout has elapsed by reading from this context like this. Okay. tx.done. If this gives me if this channel gives me a value, it means finished. We're done. Okay, and the cancel function here, I'm going to make sure to call it with a defer, so that when the call services function exits, the context is just canceled. Okay, whether there has been a timeout or not, I'm just stopping everything. So I'm going to do defer, cancel. Good. All right, and I know that in my reading of the values, when I wait for channels, I'll need to use this context.done channel to check if I still have time or not. Okay, so I'm running the service A, there's nothing changed here. Running the service B, there's nothing changed here. Here, when I read the values, is when there is a change, okay? What I'm going to do is I'm going to use a for select loop. For select loop, because I need to read two values, okay? So I need to iterate twice over my select, and the select is what is actually going to read the value. So I'm going to do for nothing in range 2 because I need two values. Okay. Here I'm going to create a select, and the select is going to read for me. So case A is equal to A out. Okay. Sorry, A out. Right. And here I have nothing to do, but I can just add some print for the video, and I can say received value from A out channel. Okay. Sorry, this is Python habits. Right. Now I can read B from B out in exactly the same way. Received value from B out channel. I don't need these anymore, and I just need to declare my A and B variable. Okay, so var A is of A output type, and var B is of B output type. Right, so I'm declaring these variables here so that I can access them in the rest of the function. And then in the nested for and select blocks, I'm reading these variables using a select statement. What happens here is select is going to execute the first statement that's ready. So let's say A out is ready first, I'm going to read from A first. Let's say B out is ready first, I'm going to read from B first. And then the select exits, and then I'm going back in the loop a second time to read the second value. Okay. So if we start here, we still don't have the timeout in our function code, but we're getting there by baby steps. So here I have a syntax error, I need to fix something. Let's see, what did I forget? Oh, of course, I don't need braces, I need colon. All right. Okay, now I have new errors, unexpected name main. So here I probably forgot to close a brace. All right. And command line arguments, channel exercise, declared and not use context. Okay, well, good. Context has not been used. Okay, we know that we haven't used it yet. I'm going to silence it by assigning it to the silent variable like this. And now the code is running. So let's see what does this code do. We're running service B, we're running service A. Service B finishes, and we immediately receive the value from B. Oh, sorry, I made it. No, I did not make a typing mistake. I see. So what happens here is when you have a closed channel, because here we close the B out channel, right? You can select will keep reading values from closed channel, and they will all be set to 0. Okay, so the question becomes, okay, I'm reading the real value from the B out channel first, and then the channel closes, and then I'm immediately ready to read the next value from B out, which is 0. And then I'm going to keep infinitely read 0, 0, 0, zeros. How do I prevent that? Right, so how do I prevent a for select loop from reading from closed channels? And that's actually quite easy. What I need to do is I need to assign B out to nil after I read from it. Okay, so when I'm done reading from a channel in the for select loop, you set it to nil. And then after you do that, it ensures that this case will never execute again. Okay, so let's try again. Here we can immediately see service A is running. Oh, and by the way, look, finally service A is running first, right? Like I said earlier, the order that they start in is not relevant. As long as they run in parallel and we get the values from them, we're fine. So here service A and B are running. Service B finishes first this time. We read the value from B out. And you can see we're not reading a second value from that same channel because we set it to nil. Now, service A finishes. It took a bit longer than service B. We get the value from the A out channel, and then we call service C. Service C is done, and everything finishes right. Okay, so we're good. We have basically almost the same code as before, just a bit more complicated with this for select loop. But now we can use the context. We can use context.done here in our for select loop to make sure that we don't exceed the timeout. So how are we going to do that? Well, the for select loop needs to read two values, A out and B out, right? Unless if we get a timeout. So we can add a new case here. Case. I don't need to assign this to a variable. I just need to read from context.done, okay? And here, I'm immediately going to print something for the video that says timeout, okay? Finished. Now, if we get in that case, we need to break the loop because we don't even need to read the next value A, B, whatever, okay? So I can just use a break statement. I'm going to get out of the loop. Or I could use a goto label, but ideally you avoid goto labels as much as you can. Right, so let's try this. If we have a timeout, we break off the loop, which means we won't read A and B. But that's okay. The channels will be closed after the values is written to the buffer, and they will be garbage collected after this function exits. So that won't be an issue for us. What we know is at this point here, we won't wait for more than the timeout. So I don't need to silence the context anymore. And I can run my code, make sure it works again. So there's no timeout, so the code works. Okay. If I go, okay, wait. So after I exit from the timeout, exit from the loop, I can't call service C because either A or B will not be initialized to the right value, right? There is zero value and I have a programming error here. What I should do is I should exit from the function and return an error that says, hey, timeout. Okay, so I'm going to change this call services and I'm going to return a C output and an error, okay, here. And in case there is a timeout, I'm not just going to break out of the for loop and then execute this code because this code becomes irrelevant. I'm going to completely return out of the function, okay. I'm going to return a zero value for C output, okay, so something that should be ignored because there is an error. And an error that says heroes.new timeout. Okay, I'm just going to make it simple here. Okay, now this is the unhappy case where we have an error. In the happy case where we don't have an error, we will call service C, we will get the C value here, and we will return a nil error, okay, meaning there is no error. Which means that in our main function, when we call the call services function, we will use the comma awk idiom. So when you call a function that can return an error, the good practice is that the error is returned as the last argument, as the last return value, and you catch that error like this, and then you use the if statement. Okay, so if awk is not nil, we have to process this. Okay, so here we can just do println there was a timeout. Sorry, okay, and we can return that. Okay, sorry, and then we can just exiting. All right. And if there's if awk is nil, it means there was no error. We get the C value and print all done. So let's try this again. The code is running as before, nothing new here. But we're going to check out that the timeout works by going into our services, service A, and increasing the duration that this service takes. So let's say that we get very unlucky and the service takes 60 milliseconds. Okay, this should not result in a successful call tree. Okay, the service A should trigger the timeout. Let's see what happens. Service A is running, service B is running. Okay, so this is according to what we expected, both servicing start running. Service B finishes first because service A has been delayed. We get the value from the B channel, that's good. And here, bam, timeout. Okay. Our context sent us a value there after 15 milliseconds saying timeout. And what happens is we're not reading. This for loop exits immediately after the return, and we're not even reading the value from A out. So that's good. So far, so good. But we're not done yet, because the timeout was for the whole call services function here. Okay. And so far, we've only applied it to the parallel call of A and B. We also need to apply the timeout to service C. Luckily for us, it's going to be exactly like what we've done before. So it's not that hard. We need to call service C in a Go routine. And when we read the value out of that Go routine, we need to read it with a timeout, the same as before. All right, so let's create a channel. C out. Okay, this is a channel of C output. And because we don't want the Go routine to hang until we read the value, because we might not read the value because there might be a timeout, we're going to make it buffer channel. Okay, because we need to write one value to that buffer, we can give it size 1. Then we're going to create the Go routine like this. Go func as before. Don't forget to call the function here, not just declare it. Inside the function, we can call the C service. And we don't forget to close the C out channel right after we write to it and write the C output to the channel. Oh, sorry, defer close C out like this. Okay. And as before, we could immediately create a variable C and read from the C out channel like this. Here we don't have the timeout logic, okay? It's just baby steps, run the code as often as you can. Ideally, write test, okay? But for this small exercise, we're not doing test-driven development yet. All right, so there's a channel after service A takes too long. Let me remove the timeout code and just revert this to 30 milliseconds. All right, and in here there is no timeout, service is called, service finishes, and all good. All right, how do I add a timeout to this Go routine? Well, exactly like I did before. So I'm going to turn this variable read into a select statement. Do I need a for loop? I do not need a for loop. Why? Because I only have one value to read, right? So I don't need to go back and read again. So I can do select. Case, I can read from C out. Okay. But I'm not going to assign the variable C here. I'm going to declare the variable C here. So var C of type C out output. Okay. Here I'm going to just assign the value to it. And in that case, I can just print something. Okay. So how did I write it earlier? Received value A from out channel. Okay, good. I'm going to write receive value C from C out channel. Good. All right. Actually, if I run the code like this, I should have exactly the same output as before. Okay, I still haven't implemented my timeout logic, but this select statement will always read hang until I have value from C out, and everything will go like we did before. Here comes the timeout logic. In case I can have something from the context.done channel. Service C timeout. Right. Let me change the output from this one here. So this one timeout was actually service A or service B timeout. Okay. Well, this one is service C timeout. And then in that case, same as before, I'm going to return an empty C output sorry, an empty C output, and a new error that just say timeout service C. Okay, the exact error here doesn't matter. All right. Let's run this code. Everything should work as before. We don't have any timeout set right now. So service A, okay, so service B and A run together. Service A and B are done. We receive values from both of them. Then we start service C. Service C is done. We receive the value from service C and everything is good. Right. Now let's try. Is our timeout on service C working properly? We're going to set service C to 50 milliseconds, and that should time out. What does the output say? Service A is running, service A is done. Okay, good. We receive the value from A, we receive the value from B, everything is good. And here service C is running. Okay, so we do start the service C, but because service C takes too long, we have a timeout. That was a timeout, sorry, exiting. Good, this works as expected. Right, now we just want to illustrate one more thing, which is that if none of the services independently time out, okay, so let's say they are all under 50 milliseconds. I'm setting them all to 30 milliseconds. But the total running time of A plus C or B plus C is more than 50 milliseconds, then I should have a timeout, right? So let's say I'm going to make service B extremely fast, and it's going to be 1 millisecond only. I should wait 30 milliseconds for A, and then I should only wait 30 milliseconds for C, but because 30 plus 30 is 60, which is more than our allocated time budget of 50 milliseconds, I should get a timeout. All right, so let's run this. And here you can see I do get a service C running and then service C timeout, even though service C is only 30 milliseconds, right? Why? Because when I create the context here at the beginning of the call services function, the timer starts immediately, okay? And so I go through this, it takes me 30 milliseconds. This is irrelevant because it's only 10 milliseconds and they overlap with this 30. So I can go through all of this in 30 milliseconds. Here I'm reading the values, I'm still at 30 milliseconds. And here, before I can reach the end of it, the timeout occurs. So service C times out. Okay. So that's it, we're done. We did call 3 web services. We added some timeout logic. And everything works as we expected. Now, what happens if service A, service B, and service C can return an error? Okay, how do I make this code able to handle errors? Well, first I'm going to add an error return value to my services. So service A can give me either A output or an error, right? And I'm going to give no errors here. Service B can give me either a B output or an error. Okay? And I'm going to give no errors here. Service C can give me either a C output or an error. And I'm going to return no errors here. All right. So when I call the services, I don't just need to get A out or B out now. I also need to know if I'm getting an error. And here also, I'm going to need to update the variables. Okay, so let's just say A, OK, is equal to service A. If we are not OK, then I need to write the error to some channel, or I need to do something. In this case, I'm just going to write it to a channel. Okay, so I'm going to create an error channel. Just going to make a channel of error, right? And we'll see later how much we want to buffer this. Let's just write this. Let's wire everything first. Okay, so if it's not okay, I'm going to write the error to the channel. Okay. Okay, actually, let me get some consistency here. I'm going to error out. Okay, maybe E out. There. E out for errors. I'm going to write the error to the channel E out. And obviously I don't need to write here to A out anymore because this value can be ignored. So I can write an I can just return. I like not nesting the happy path. It's good that the happy path is allowed on the left here as much as possible and not nested inside an if or a subblock. So instead of doing an if else, I'm just going to return from the function here. Okay, so if we go in that if, the function returns we're out. If we don't, we just write the A out as before. All right, let me put this in B out. Same logic as before, okay? So I'm adding a variable to capture the error from service B. If there is an error, I'm gonna write it. Okay, so where do I write it? Do I write it to errors for B, and then I can rename this channel errors for A? Or do I want to capture them to the same channel? That's a good idea. I mean, it's a good question. Since they're the same type, and since I can probably process them with the same logic, I mean, an error is an error, right? Here I'm going to write them to the same channel, okay? And because I have two routines that write to the same channel, I can give it a buffer size of 2, right? So we know that the A go routine will exit whether it writes to A out or E out immediately because there is enough buffer space in each case. Now, if the A routine has written to the error channel, I need a bit more space in case the B routine also writes to the error channel. Okay, so that's why I need a buffer size of 2 here. Right, so if there is an error, I'm writing it to the E out and I return. If there is an error, I'm writing it to the E out and I return. Same logic here. Now when I read, when I read the values out, I also need to read errors, right? Now the beauty of it is I only need to read 2 values total. Okay, I don't need to change this for loop here. Why? Because let's say A gives me a real value, I read it. And B does not give me a value, B gives me an error. Well, I don't need to read the B value and I'm done. If A gives me an error, I can immediately exit. So either way, I need either 2 values or 1 value, but not more than 2. So I don't need to increase the range here. Right, so happy path, I get a value from A. Happy path, I get a value from B. Now, unhappy path, I get an error. Let's say E, which I read from the E out. Okay. What do I do in case of an error? Well, if either A or B give me an error, I won't be able to call service C. So there's really no point in continuing. So just like when there's a timeout, I can immediately return and return the error basically, right? So I'm gonna make a print for the video and I'm gonna say service A or service B, I don't know, either of them, errored. Error, yeah, okay. And here I'm gonna return empty value and let's just make it simple for now and just create a new error. We could wrap the error, return that error. Doesn't matter. That's not what we're focusing on right now. I'm just gonna return a new error like this. Okay. Since I did not use that value, I can just remove it like this. All right. Now, what happens if there are errors in the service C? Okay, first, let's capture the error from the service and do the code that we know we will need. Okay, so if OK is not OK, if it's not nil, what do we do? What do we do with the service C error? Well, we need to write it to a channel. Question is, do we create a new channel or do we reuse our error channel? We can reuse the error channel, and here's why. Let's say that both A and B write to the error channel. Now the buffer of my error channel is full, okay? Which means that if C tries to write, it will hang. It will hang until the buffer gets the next available space. But in that loop, if I know for sure that I read the value from E out, then the buffer has one available space from my C routine and I'm good. Except I don't know that I will read from E out because I might just have gone through the timeout. But if I'm going through the timeout, the function has exited and it doesn't matter because I'm not running C anymore. Same here. If I got a value in E out, the function has exited and I'm not even calling service C anymore, right? So when I'm here, when I'm calling service C at this point, I know that the E channel is empty. Otherwise, I would have exited the function before. So I can just reuse it, okay? Here it depends on what you want to do with the errors, but since we're just ignoring the errors for now, I can just store it in there. So I'm going to write the error to the E out channel. And for the sake of the video, I'm going to add a nice print output. I'm trying to find my... Oh, I do not have print outputs. Okay, well, I'm going to add print output for everything. What do I want to write? Println read an error from service A. Okay. Or let's say got an error from service A. All right, here, got an error from service B. And inside my CGO routine, where's my CGO routine? Here, got an error from, why am I writing it? Am I writing it before or after? All right, so here, got an error from service C, and I terminate the Go routine before attempting to write to C out. All right, and then here, same as before, in the select case, happy path, we get a value from C out. Unhappy path, we get an error instead, okay? So case, I got something from the E out channel. And here, same as before, I'm just gonna add a print, got an error, and then return. No, sorry. Same as before in the case here. I'm gonna make a print and then return. Okay. So here I'm gonna print service C errored. And I'm gonna return an empty value with a new error. Okay, so error from C. Yeah. All right. Okay, let's try this code. Let's run it, see if there are no typing mistakes. We get a happy path everywhere. No, sorry, we get a timeout. All right, so service A and B are running. We get good values from both of them, no errors, but then we have a timeout when running service C. So let's go in our services and see what's up. Okay, service A is 30 milliseconds. Service, oh, I'm having trouble speaking. Service A is 30 milliseconds. Service C is 30 milliseconds, and that's too long. Let's put service C back to 10 milliseconds. 30 plus 10 is only 40. We should have no timeout anymore. And it's working. Right, now let's change service A to return an error. Okay, so errors dot new, and yeah, just some random message. Here, we expect the function to call service A and service B and immediately return with the error from service A. Right, so we're calling service A and service B. Because service B is so much faster, it's only 1 millisecond, we receive the value on the B out channel. And then we receive the error, here got an error from service A, we receive the error from service A. Either A or B errored, we don't know which one in the upper level function. And here it says there was a timeout, sorry, exiting. We don't want that there was a timeout. And that's probably because in our main function, we did not account for the error. Okay, so there was an error. Sorry, that's much better. And let's do something. Let's just print the error actually, right? So there was an error, okay, dot error. Let's see. Yeah, there was an error. Okay, it's not a timeout. That's better. Actually, consistency is a good thing. So if we look at our messages here, received value from B out channel, when we get the error, we want to receive the error. It's going to make it easier for us to understand what statement has sent this text here. So got an error from service A is inside the Go routine. Go got okay. Easy for us to identify. Got an error from service C, go got good. In the select case, we want to use received. Okay, so I'm going to write here received error from E out channel from the service C. Right. In here, I'm going to say received timeout from context service C. And that's much better because this consistency will, I mean, here it's a very simple problem, a simple exercise, right? But will allow us to understand what is happening a lot more easily. Now in this select, here I have another select for A and B, right? I'm going to use received also. So received error from E out, and I'm going to say service A or service B. Right, and in the context, I'm going to say receive timeout, service A or service B. All right, now if I run this code again, it's a lot easier to understand. Service A is running, service B is running, service B is done. We do receive the B value from the B out channel. Service A is done, and this time we don't. Okay, so this is in the Go routine that says error from service A. And this is when we read the value out of the E out channel for service A. Okay, so got is from the Go routine, received is from when we read the channel. Good, so the error from A is well detected and the C service does not run. If I were to change the error and put it inside the B service, I would have exactly the same. Kind of code. So now let's put an error in. Oops, sorry. Let's put an error in the service C and see what's happening. Service B and A are running. Okay, service B and A are both done and writing the value to their channels. Now service C is running, service C is done, but we don't get a value. In the Go routine, we get the error from service C, and at the select statement, we receive the error from the E out channel. And the main function prints the error from C. So everything works as expected. We have some proper error handling. And that's it. Okay, I hope you enjoyed this coding session. Very soon we will add some test-driven development to our exercises. And I'll see you guys in the next video.